1.5, we're going to be analyzing graphs of functions. So first thing we're going to look at is zeros of functions. So if the graph of a function of x has an x-intercept at a point where y is 0 and x is some number, then that number is the 0 of the function. So your function is when y is equal to 0. Your 0 of the function. So if it gives you an equation, all you need to do is set y equal to 0 and solve for x. And those are your zeros of the function. So essentially you're just solving for x.
The zeros of a function is solving for x?
Yeah. It's like zeros, solutions, I think like factors, all kind of mean the same thing. So it's just like a solution to the equation. On a graph, your zeros of the function would be where it crosses the x-axis, because that's where where y is 0. Yes. So starting with the first one, we said we change y to be 0. So I'm going to change this f of x to be 0 is equal to 3x squared plus x minus 10. Anybody remember how to solve for x when you start with a number that's not 1?
Factoring?
We factor it, but how do I factor here? Because this 3 is kind of throwing us off. Awesome. We can multiply the 3 with the negative 10. This is how I do it. The last class liked to do it a different way, which I'll do it that way also, just so we can see. So if you have never done it this way, I'll do it another way after.
Yeah.
Okay. But we can multiply the 3 and the negative 10. We get negative 30. Then we see what are two factors of negative 30 that add to the middle number here, which would just be 1. So what are two factors?
Negative 5 and 6.
Negative 5 and 6. So we factor it just like we would normally. So x minus 5, x plus 6. And then because we started with this number out front that's not 1, we divide both of our numbers on the inside by that number. So if it simplifies, we simplify it completely. If it doesn't, what do we do with it? Put it in the front. So this 3 would come to the front.
Wait, how do you put 3?
Because we started with the 3 there.
This is just an easier way of doing it.
Yeah.
So I just put the 3 in there and then just, do it like that. Not like that, but like, I just do 3x minus and then x plus something.
I'll do it the other way next, so you can see. And you can pick whichever way you like to do better. All right, this is still equal to 0. What should I do next to solve? Before I do that, Matthew. Set them both equal to 0. So 3x minus 5 is equal to 0. X plus 2 is equal to 0. Now I can solve for x. Kayla.
Why can you multiply the x by the 3? I don't get how you can do that.
So that's just our way of factoring because I multiplied the first and the last, got negative 30. My two factors of negative 30 are negative 5 and 6, and I have to divide by this 3. If it doesn't go in evenly, like here, we can't divide 5 by 3, I move it to the front.
Oh, okay. I remember that now. I was just kind of confused, like, why was that? It looked like you were dividing by 5. Okay.
So then I just solve for x. So add 5 to both sides, divide by 3. So x is equal to 5 over 3. And then here, I'm going to subtract both sides by 2. So x is equal to negative 2. So my two answers are negative 2 and 5 over 3.
Isn't there a thing where it's like that if certain conditions are met, any negative numbers can't equal that?
I'll show you the other way. The last class liked to factor it this way. So we had 3x squared plus x minus 10. They multiplied the first and the last and got negative 30. And then they said, what two numbers can I multiply that gives me negative 30? So they picked 6 and negative 5. So they split up the x in the middle to be 6x and negative 5x. So they had 3x squared plus 6x minus 5x minus 10. Anybody do it this way? A couple people. Okay. So then since we have 4 terms here, we can factor by grouping. So I group the first 2, group the second 2, and I take out what I have in common. So what do I have in common in my first parentheses? 3x, and then I'm left with x plus 2. What do I have in common in my second parentheses? -5, and I'm left with x plus 2. So since my parentheses are the same, I combine them to one parenthesis. And then I take whatever I have on the outside and put those into another parenthesis. So 3x minus 5 times x plus 2, which is the same thing that I had here. All right, let's look at B. So again, I'm trying to find my zeros, so I want to set this equal to 0. So I change my g of x to be 0. What should I do to solve for x? Square both sides. What's 0 squared? 0. And then the square root and the squared cancel. So I have 10 minus x squared. What can I do next to solve for x?
Like the little 2 and then the x and x, because it's a square, x squared.
Or you could just minus 10.
You could add x2 to the other side.
I could minus 10, definitely. But to skip a step, I'm going to add x squared to the other side. I could minus 10, divide by negative.
Oh, okay.
Either way would work. But I'm going to add x squared just so it cancels out there.
You take the square root of both.
And then I can take the square root of both sides. So what's x going to be equal to?
Square root of 10.
What's the one thing you can't forget when you take the square root of both sides?
You have to take out, I don't know, plus minus.
Plus or minus. Plus or minus square root 10. C. 0 equals 2t minus 3 over t plus 5. What should I do to solve for t?
Multiply by t plus 5 on both sides.
I can multiply it by t plus 5 on both sides because it'll get rid of what's in the denominator, so it cancels out on the right. And what's 0 times t plus 5? 0. So I get 0 is equal to 2t minus 3.
Wait, so you just got rid of the bottom altogether?
I multiplied both sides by the denominator because it cancels out on the right. And then t plus 5 times 0 is 0. I'm going to add 3 to both sides. So 3 is equal to 2t. Divide by 2. T is equal to 3 halves. So another way we could think about this one, which ends up being the same, we're setting this equal to 0. Anytime our numerator is 0, the entire fraction is 0. So I could just set my numerator 2t minus 3 equal to 0. Because if I had 0 over 10, what is this? 0. What about 0 over 500? 0. So when your numerator is 0, the whole thing is 0. So I just need to set the top equal to 0. On the next page, example 4, you guys did questions like these on the quiz. It's just use the graphs to describe the increasing, decreasing, or constant behavior of each function. So we're going to assume that these are arrows here. What is our interval of increasing? Awesome. Negative infinity to infinity. Are we decreasing anywhere? Nope. What about constant? Nope. All right, next one. Again, these are arrows here. So where are we increasing? Awesome. Negative infinity to -1. And where else? From 1 to infinity. And then where are we decreasing? -1 to 1. And then are we constant anywhere? No. And then again, these are arrows here. Where are we increasing?
Negative infinity to 0.
Negative infinity to 0. Where are we decreasing?
To negative, no, to negative infinity.
2 to infinity, because it's pointing to the right, because we're looking at x values. So even though it's going down, that would be like y values. So it's going to the right, so it's getting bigger, so infinity. And then where are we constant? 0 to 2. All right, you guys should be professionals at this by now, because that was on your quiz yesterday. Any questions? Next page. All right, so next we're going to look at the average rate of change. Average rate of change is the same thing as saying the slope. It's just the slope you would have in a linear graph, so a straight line, you would find the slope. We call it the average rate of change when it's a non-linear graph, just because we couldn't find the slope of this curve here. What we would do is pick 2 points and then find the slope of the straight line that connects those 2 points. So it's the average rate of change between 2 points. Same formula as the slope. So what's our slope formula?
y1 minus y2 over x1.
y2 minus y1 over x2 minus x1. So it gives us an x1 and an x2. How do you think we can find the y's that go with each of these? What's y1? How do you know it's -2?
Because that's the y coordinate on the graph.
So when x is -2, y is -2. So I go to where x is -2 on my graph, find that point, and my y is -2 there also.
I'm sorry, could you repeat that, please?
So I go to where x is -2. So that's to the left too. And then I'm looking to see what my y is at this point on my graph. So y is -2 when x is -2. So that's why my y1 is -2. Another way we could find y is by plugging it in. This is our function here. So this corresponds to the graph here. We can plug in -2 to x to find y here. So I would say -2 cubed minus 3 times -2. What's -2 cubed? -8. -3 times -2? +6. And -8 plus 6? -2. So my y would be -2. So you can either look at the graph or you can plug it in.
Plugging in x for,
Plug in x to find your y.
so they can either give you the function or the graph?
Yeah.
Will there be like a question where they don't?
So when x is -1, what's our y?
2.
Awesome. That's this point up here. So when x is -1, our y is 2. So y2 would be 2.
Is this, so we just do this?
So now we plug in our y2, y1, x2, x1 into our slope formula. So we have 2 minus -2 over x2 is -1 minus -2. So we got 4 on top and 1 on the bottom, so our slope is 4. So this is our average rate of change. Same thing as the slope. All right, let's do the next one. So now we're trying to find the average rate of change from 0 to 1.
Wait, sorry, can you go back?
So when x is 0, what's y? 0. So again, you can either look at your graph or you could plug in 0 here. We'd have 0 cubed minus 3 times 0, which is just 0. And then when x is 1, what's our y? -2. That would be this point here. So when x is 1, y is -2. So now we just plug it into our slope formula. We have -2 minus 0 over 1 minus 0. So this would be -2 over 1, which is -2. All right, last thing we're going to look at today is even and odd functions. So a function is even when you plug in a negative x in place of x and you get the original answer. Original function. So you get the original function. And then it's odd if you plug in a negative x and you get the opposite function. So again, we plug in a negative, but we get the opposite version of our function, so the signs in every single term in our function change. The opposite.
Every single one.
Every single one has to change.
What's just one?
Couldn't you basically tell if it would be odd or even based on the exponent?
Kind of, but just because it has an even exponent doesn't mean it's going to be even every time. And just because it doesn't have an odd exponent, it's not going to be odd every time. All right, so next we're going to look at graphs of functions and determine if they're even, odd, or neither. So if it's an even graph, it's going to be symmetrical on the y-axis. So the y-axis is like the vertical one here. So our graph would be symmetrical on the y-axis. That means it's going to mirror on the left side and the right side. It'll be the same shape on the left and on the right of that y-axis. If it's odd, it's going to be symmetrical on the origin. So meaning like this axis here when x is equal to y. So that kind of diagonal there. So to check if a function's even, we check and see if it's a mirror image on the left and the right. To check and see if it's odd, you just take the graph and flip it upside down, and if you get the same exact thing upside down, it's odd. So just take your iPad, flip it upside down. If it's the same graph, it's going to be odd. So let's look at this one. If you take your graph, flip it upside down, notice that like the left arrow is pointing down. So like it's in the left lower quadrant pointing down. If you take your iPad, flip it upside down, the left lower quadrant is pointing down. So it's the same exact graph upside down. It's symmetrical on the origin, which is like the x is equal to y-axis here, this diagonal.
So, can you repeat that? Like, why is it the opposite?
So to determine if it's symmetrical on the origin, you take the graph and flip it upside down. So like all the positive x and y values are going to be the same in the negative.
So what are we answering, whether it's
Even, odd, or neither. So because this is symmetrical on the origin, if you flip it upside down, you get the same exact graph. This is odd.
and if it's not symmetrical, then it's
if it's symmetrical on the y-axis, so let's look at the second one. Our y-axis is this. Do we have a mirror image on the left and on the right? So this would be even. If it's neither symmetrical on the origin or symmetrical on the y-axis, it's neither. So it can be, this is symmetrical on the y-axis. Our y-axis is here. It's symmetrical, meaning the left and the right are the same.
So you see if they're symmetrical or the way, aren't they both symmetrical?
This one?
Yeah.
To check and see if it's symmetrical on the y-axis, it would be a mirror image on the left and the right. So whatever's happening on the right here would also happen on the left here. Like it would be a mirror, same exact thing.
So they're not symmetrical.
So this one's not symmetrical on the y-axis, so it's not even. So we have to check and see if it's odd, and to check and see if it's odd, flip it upside down.
Okay, so for odd, it's symmetrical if it goes through the origin.
If it is symmetrical on the origin, it is odd. So on the next page, we're going to do some more examples. I'm going to look at the graphing ones first, and then we'll come back to the top ones. So number 6. First thing we want to do is check and see if it's symmetrical on the y-axis. Do we have a mirror image left and right? Yes. So is it even, odd, or neither?
Even.
Even. Number 7. Do we have a mirror image on the left and the right? No. So it's not even. What about if we flip it upside down? Do we get the same exact thing?
Yeah.
Are you sure?
Oh, no.
So notice how like this piece here is in the upper right-hand quadrant. Okay? If you flip it upside down, it is now in the lower left. So this would be neither. If it went through the middle and you flipped it upside down, then it would be odd. So this is neither. So if I had an example here, I'll do another one that goes through the middle. So this goes exactly through the middle. I'm looking, it goes up in the right-hand quadrant, down in the left-hand quadrant. If I flip it upside down, it goes up in the right-hand quadrant, down in the left-hand quadrant. So this would be odd. But what makes this not odd is this piece, because it throws it off a little bit. All right, and number 8, what do you think? It's odd. So it's not symmetrical on the y-axis, because this would go here if it were. But if we flip it upside down, we get the same exact shape, so it is odd. You guys good with the graphs? Okay. So let's look at number 1 here. So I'm going to plug in 2 and negative 2. So f of 2, f of negative 2. So when I plug in 2, I have 2 cubed minus 6 times 2. And then if I plug in negative 2, I have bless you. Negative 2, bless you, cubed minus 6 times negative 2. So let's solve the positive one first. 2 cubed is 8 minus 6 times 2, which is 12. What's 8 minus 12? Negative 4. Next one. Negative 2 cubed is?
Wait, so it's 9?
We have to do both to see if it's the same answer, then it's even. If it's opposite answers, it's odd. If it's different answers, then it's neither. So we have to solve both. So negative 8 plus 12, what negative 8 plus 12 is? 4. So are these the same?
Opposite.
They're opposite, so is it even, odd, or neither? It is odd.
I did the negative x thing that you did and I got even because they were both like different.
So let's do the negative x. So negative x cubed minus 6 times negative x. Negative x cubed is? Negative x cubed. Negative 6 times negative x would be positive 6x. So my signs change for both of these. So if it's the opposite version of it, then it's odd.
That's what I got.
No. Even as if it's exactly the same. All right, so you guys good with that? Let's look at 2. So we can plug in 2 and negative 2. So 2 to the 4th power is what?
16.
16. And 2 to the third power? 8 times 2? 16. So we get 0. Now let's... Oh, sorry, third.
So you square, I mean, you cube one of the two and then you multiply?
I plugged it in here. So I just did what the equation told me.
Yeah, so on the 2 and then parentheses 2.
So 2 cubed is 8, and 8 times 2, 16. So negative 2 to the fourth power would be 16, minus 2 times negative 2 to the third power. Negative 2 to the third power is what? Negative 8, and negative 8 times negative 2, positive 16. 16 plus 16, 32. Neither. All right, the next one, this is supposed to be x squared. It got cut off in the last page. So let's plug in 2 and negative 2.
Shouldn't you read it? Oh wait, never mind.
So 2 squared plus 2 times 2 plus 1. 2 squared is 4. 2 times 2 is 4. 4 plus 1 would be 9. Then plug in negative 2. So I have negative 2 squared plus 2 times negative 2 plus 1. Negative 2 squared would be 4. 2 times negative 2 is negative 4 plus 1. What's 4 minus 4 plus 1? 1. So what would my answer here be? Neither. All right, number 4. I'm going to plug in 2 and negative 2. So I have 2 squared plus 6, which is 4 plus 10. 4 plus 6 is 10. Then I plug in negative 2, so I have negative 2 squared plus 6. 4 plus 6, which is 10. So are these even, odd, or neither? 4 plus 6, which is 10. So these are even because they're the same thing. And then last one, number 5. Again, I'm going to plug in 2 and negative 2. Which you guys could plug in any number. Like let's say you wanted to do 4 and negative 4. You could do that and it would still give you the same answer. I just like 2 because when you're going to cube it, it's the easiest one to work with. It's not fun to cube 5. All right, so plug in 2. 2 cubed plus 7. 2 times negative 2 cubed plus 7. So 2 cubed is 8, and 8 times 2?
16.
And 16 plus 7? 23. For the next one, negative 2 cubed is negative 8, and negative 8 times 2? Negative 16 plus 7? Negative 9. Even, odd, or neither? Neither. Do you guys have any questions on what we did today?